Hello, my name is Christian Madera Diaz. I'm a metrology technician and an industrial engineering student. Today I'm presenting Engineering Human Factors, Advances in Military Aviation, Warfighting, and Operations Safety. Before we begin, here is an overview of what we will be covering today. This table of content outlines the key sections of my presentation. We will start with an introduction to human factors engineering, where I will define the concept and importance in military context. Next, we'll move into specific application of human factors engineering in military aviation, including the redesign of the B-52 cockpit and the C-130 Hercules cockpit, environmental changes in aviation, fatigue management in pilots, and the key findings and conclusion. Human factors engineering is a scientific discipline that focuses on optimizing the interaction between humans and systems. The International Ergonomics Association defines HFE as the application of theory, principles, and methods to design systems that enhance human well-being and overall performance. In the military, human factors engineering plays a critical role, ensuring that personnel can effectively interact with highly complex systems like unmanned and aerial vehicles, fighter jets, and simulators. Technological advances has the need for new interfaces, workflows, and training strategies. For examples, the U.S. Air Force uses HFE to equip pilots with tools and systems that enhance their decision-making under high-pressure scenarios, allowing them to focus on critical tasks like combat. A well-known application is the B-52 bomber, where missions can exceed 30 hours as seen during Operation Desert Strike, where crew executed a 34-hour missions with the aid of aerial refueling and augmented crew. Beyond aviation, human factor engineering is also crucial in developing autonomous systems such as unmanned ships, which require adaptable design to align with human capabilities and limitations. By addressing challenges like fatigue, visual perception limits, and cognitive workload, human factors engineering ensure operational outcomes are optimized. This presentation will explore how human factors engineering continues to enhance military operation, improve safety, and integrate advanced technology. The B-52 Stratofortress has been a critical part of the U.S. Air Force since its introduction in 1955. Known for its endurance and versatility, the aircraft has remained operational for decades due to continuous upgrades and innovation. This bomber can carry both nuclear and conventional payloads and is capable of flying at high supersonic speeds at altitudes up to 50,000 feet. One of the standout features of this is the range, which can extend to 8,000 to 9,000 miles without refueling, making it indispensable for long-range missions. Initially, the B-52 cockpit was entirely analog, as you can see in these pictures in the middle. Uh, it have like all the altimeter, rate indicator climbs, and like pressure gauges analog, which require the pilots to manually process information from multiple dials and gauges, which increase cognitive workload and response times. And now they redesign it completely, as you can see in this picture over here, uh, where now the new cockpit is integrated advanced digital displays and update systems, and these upgrades not only enhance situational awareness but also streamline operation by reducing the pilot workload and decision speed. These upgrades were tested in a simulated environment to ensure usability under real-world conditions. Next, we have the redesigned cockpit of the C-130 Hercules. The C-130 Hercules is a versatile aircraft of the U.S. Air Force, widely used for tactical airlift, humanitarian missions, and combat support, and it has been operational for decades. One of the most significant advancements is the new cockpit redesign, which replaced the older analog, as you can see in this picture over here. There was a picture from the older one, and it was replaced in 2017 for this new uh, cockpit, which is digital completely. Then you have a new interface that provides pilots with quicker access to mission data, allowing them to make faster and more accurate decisions. For example, tasks like inputting latitude and longitude coordinate, which previously required several minutes using laptops or tablets, now can be done in less than 30 seconds with a new glass touchscreen display. Then another crucial upgrade is the integrated terrain awareness and warning system, and you can see it over here and here, uh, which provide real-time alarms for potential terrain collisions and alerts for nearby aircraft. This enhanced situational awareness, particularly in low visibility or high stress scenarios for the pilots. These upgrades were tested, including simulated environments in Eglin Air Force Base, and they reflect the integration of human factor engineering, reducing pilot workload and increasing operational safety. The intuitive design also minimizes the chances for error during missions, and the modernization of the C-130H demonstrate how the Air Force leveraged human factors engineering to extend the operational lifetime of legacy aircraft while enhancing their capabilities. Environmental challenges and risk management. So in battlefield scenarios, environmental factors such as terrain, weather, and lightning pose a significant challenge to operation effectiveness. For instance, low light conditions and atmospheric scattering can impair detection ranges and limit situation awareness, making it harder to navigate and detect threats. Research into night vision systems highlights how optimizing photocathodes materials and adjusting spectral response ranges can mitigate this limitation, ensuring soldiers have the tools to perform effectively even in most adverse conditions. These challenges are not limited to battlefield ground operation but extend to normal aviation as well. For example, the safety upgrade of the C-130 that I talked about in the previous slide is designed to detect when the aircraft is approaching the ground too closely and provide early warnings, giving the crew ample time to make course corrections. This can be used for humanitarian transportation flights, so it can actually help in both warfighting and normal aviation. Such systems ensure that pilot maintain situation awareness, especially in low visibility scenario, improving safety across a wide range of operations. Uh, Other topic is risk management. It's critical in human factors engineer because they play a key role in the process by identifying, analyzing, and mitigating risks. For example, risk mapping techniques evaluate human-related factors by categorizing risks such as cognitive errors, environmental stressors, and organization shortcomings. Next, we got fatigue management in pilots. Fatigue is a critical issue in the military aviation where long missions and high cognitive demands can significantly impair performance. For example, the standard allowed flight time depends on the aircraft mission, but normal is 12 hours and commanders have the authority to extend the flight time for 2 more hours. We have seen examples like the B-52 bombers crew that has faced missions exceeding 30 hours. And the extended duration and high stress of these operations increase the risk of errors and accidents, making fatigue management a priority. Uh, I have a quote from Major Leclerc article where he emphasized the importance of addressing human-related errors, which accounts for approximately 70% of aviation accidents, as critical to maintaining and improving safety. Uh, Knowing this stat, like 70% of aviation accidents are because of human error, we can observe how human factor engineering plays a key role in addressing fatigue by designing tools and systems to monitor and mitigate its effects. For example, they created like a real-time facial expression recognition system for remote pilots that provide early warning of fatigue-related impairments, allowing them for timely interventions. Another one is educational initiative also focus on improving sleep hygiene and awareness of fatigue. These programs help pilots understand the importance of rest and providing strategies to maintain alertness during missions. Such training ensures pilots are better prepared to manage fatigue, enhancing their performance and operation safety. Uh, they also, in extreme cases where mission takes precedence, they may opt to use stimulants, commonly called like the gold pill, which help them mitigate the effects of fatigue and like in extreme weather or like extreme long missions. And then advances in technology such as automated workload distribution systems help reduce the cognitive demands on fatigue personnel, enabling them to focus on critical tasks. And all these systems, combined with proper training and monitor, create an approach to manage fatigue in aviation and safetyness of the mission. Throughout this presentation, we have seen how human factor engineering drive advancements in military aviation and operations. For example, modernized cockpits designed like those in the B-52 and the C-130 Hercules that streamline pilots' workload and improve situational awareness. We also discuss how environmental challenges such as low light and adverse weather affects the operation safety, and how fatigue remains a significant challenge. We also explore how risk management strategies such as risk mapping help identify and address vulnerabilities in both aviation and battlefield operations. And in conclusion, human factor engineering is critical for aligning human capabilities with advanced military systems, ensuring usability, safety, and efficiency of the mission. And these are all my reference. And if you guys have any question, please don't hesitate to comment or ask. And thank you for listening.